And yeah, so like I could kind of just mentioned, we're technically going a little bit slower than into section 8, which this week is like section 8, section 9. Like I said, MongoDB, NoSQL, section 8. And then tomorrow we should be talking about APIs, JSON, and stuff like that, which will be pretty cool. That will also be related to the project you guys are doing, basically data acquisition. And so I think it'll be a really fun thing. I have a little activity built around APIs, so we'll see how that kind of goes and everything. It's also really cool because you can like pull in data from other places, and so it's kind of a really cool way to like get new data and stuff like that. And you can also get some really interesting like real-time data as well. Okay. But today we're actually going to go back to section 7, which is going to be kind of SQL stuff. And one reason why I'm kind of making sure I take some time on this is because I think SQL is one of those things where, as a data scientist, it's really like, I think it's one of those things that's really easily abused, in the sense that like, not abused, sorry, like forgotten. So more like, I guess, neglected, is that data scientists like, oh, SQL, it's like, it's not super complex. You're not going to do machine learning on SQL. You're not doing really fancy, amazing things with SQL, but they can be really useful because it's kind of like your first interaction with data. So we're going to talk a little bit about like where you would use SQL. And what's kind of cool is that SQL's been around for so long, is that most places will have some SQL implementation already like in place. So if you know SQL really well, you probably can interact with, a lot of different data sets and stuff like this. So it's a good thing to know. So let me go ahead then and pull up. That's not the right. I got too many windows, as you guys already know at this point. I can never find Windows. Where is it? Oh, okay. I was on it to begin with. Okay, I'm going to share my screen, and you guys can check this out. Cool, cool. All right, we're going to start with the SQL lesson. So like I mentioned, we are, where did you guys go? There you are. Okay. Like I mentioned, we're going to talk about SQL first. So I'm kind of going to introduce a little bit to it. We have a little bit of like examples and stuff like this, and talk about like what SQL is. And this will be mostly review for section 7, but we'll also go into some a little more advanced topics too if we have time, right? So just kind of a quick thing. This was a lesson that I had put together with another instructor before. So I've kind of modified it. It might be a little bit different from, I might kind of deviate from it just so you guys know from what it shows here. So one thing I'm kind of asking is that what overall just questions you guys have, or, something you're like, hey, like, can we talk about this? Maybe not today, but maybe even like in the future about SQL. So anything that like sticks on your guys' mind, you're like, yes, I'd love to talk more about this, or questions specific.
We talked about this earlier, which you explaining it really helped, but subqueries.
Yeah, subqueries. Subqueries are a fun beast. Okay, give me a thumbs up if someone else is like, yeah, subqueries is, I'd like to learn more about that. All right, I see Nadine go that. Cool, awesome. Anything else that kind of sticks to your guys' mind when I say SQL and you're like, ooh, like, I don't know about this? No, nothing in particular?
I guess it's when to use like pandas to manipulate it, or when to go to a SQL query.
So like when to use the pandas stuff versus like SQL and stuff like that.
Yeah, just like if there's a better one to use for something or another.
Yeah, that's a good question. And we'll talk a little bit about that, about like why even use SQL? Like, why not just like use pandas for everything? Okay. Anything else you guys have any questions or things that you kind of like, I'm not really sure about? No? Pretty good. Okay. And I'm sure maybe there's just overall just like, maybe it comes to you later on or something like that, or you're just feeling, oh yeah, I just want to kind of know the general SQL, or maybe you're feeling like, you're like, yes, I got this down. Like I'm feeling pretty good about SQL. I will tell you, I learn new SQL stuff all the time. It's kind of fun where I'm like, oh, there's a new thing I never even thought I could do. So just know that you'll always be new stuff, right? Which I think that's a good thing, because there's always new things to learn. All right, so just kind of quickly going through this, what we might kind of deviate from this, but basically we're going to build some functions to perform queries. So instead of like typing that whole SQL-like thing, I am not a huge fan of typing a huge amount. We're actually going to use some functions and stuff like this. And then we'll also execute a query with multiple joins. So kind of show you how like you can do joining together multiple tables together to get your results. Okay. Some objectives. So we are going to create a data frame, a pandas data frame using query, using SQLite. So, or SQLite 3. SQLite 3, again, is a package, right, to interact with a SQL server in Python. We'll also compare and contrast data frames. So kind of what Nadine was asking about, like pandas versus like SQL. And And then we'll look at writing a single query, which is like a single join query, and then multiple joins. Okay, we'll see if we have enough time to really go into detail. Okay, so I'm going to kind of skip over this outline because we're just going to go right into it. So, an introduction to SQL. New notebook. All right, and oh, for the record, again, all these notebooks are online. So if you guys ever want to like go back to it and play around with it or review it, you can definitely do that. All right. So first thing about SQL, we should probably talk about is like what is a database. So anyone want to define what a database is, at least maybe from curriculum, maybe from experience, you know, what you've heard on the internet and stuff like that?
Information storage.
So it's something to store, storage. Yeah. Yeah, so a database is kind of interesting. When we usually talk about databases, we're talking about something that's like tabular data. So a table of data. So think like Excel sheets, right? Or a CSV. Note that it's not necessarily the same thing of all data, right? So one thing you might have is something later on we'll talk about are like data lakes. Data lakes are kind of just like, if you imagine a database, like when we're usually talking about database like this, we're usually talking about like nice order, you know, like, oh, Excel sheet stuff. Maybe there's missing data, but you know, it's got an order to it. Data lakes are kind of just like you dump everything in there. You're just like, images, videos, streams, whatever, just dump it all in. Databases usually when we talk about, usually it's kind of like the same thing as we're talking about like a data warehouse. You'll hear those terms used pretty frequently back and forth. So SQL actually does really well with like databases, data warehouses, things like tabular data. Okay, so a database structure, this is where we have something called a schema. And so I actually don't remember if the curriculum mentions the word schema. Give me a thumbs up if that sounds familiar. Okay, cool. So one thing about a schema basically is kind of a collection of different tables and stuff like this. And this is where I will say not mess up, but like I will mix these two things up. And if you talk to someone who's like really like particular, they'll say that's not a schema. A schema is this. So you can kind of think of like the database as like all the data. And a schema is kind of like the folder within the database. It's like, oh, this is the certain tables and data for within the database. And this might happen because maybe different teams are working on different schemas and stuff like this. So in general, we have something like this guy. And I want to say this happened before. This has been a while since I looked at this particular lesson, to be quite honest, is that I think the curriculum calls this a schema. Is that right? Yeah, technically that's not true. Technically, this is actually an ERD. So everyone says this different, like mixes these up. A schema is technically like the structure like of like what's in it. And an ERD, which I can never remember. Let's see if I can find it up real quick. Entity relationship diagram. So basically the idea there is how things are related with each other in a SQL database. So you can say this is an ERD, like so a lot of people will just call it schema. I've heard people in very professional settings, like who are like 20 years experience, are easily just call this a schema too. Just kind of know there's a difference. But note that this is a relational database. Relational basically means that you have different things relate to one another. So you can see here, these boxes are representing tables of data. And then these tables are related with each other. That's where these little connections are and stuff like that. And that's essentially what you're doing with SQL. You're kind of like looking at a table, selecting different stuff, and then combining tables together to get multiple like results or like, you know, relationships with each other. Usually this is kind of like something that would be given to you by a business. There are some programs you can like run on SQL servers that will actually like produce this ERD and stuff like this. But in general, this is kind of given to you by a business. I will tell you is that these things are not always up to date. If a business kind of gives this to you, kind of take it with a grain of salt and know that like maybe these things like are like it's up to date, but there could be new things or not, you know, quite right and stuff like this. I've come across some of those in the past. Also know just because it's here in the ERD, it's in the schema, it might not necessarily be used. So sometimes you'll come across things like, let's say, product lines, like, oh, cool, product line. Like, oh, that's actually really useful for my query. And you try querying product and you get like all null values. Turns out like, it's like, oh, and you ask like the business, like, hey, like, what's up with product lines? So like, oh yeah, we don't use that at all. It's just an empty table. And that happens a lot of the time. So just be aware is that your best connection is always talking with the person who is managing that database. Okay. Any questions on this guy? Cool.
Yeah,
Yeah.
in the employee table, the sign that's it's pointing to itself. I don't know what these things are called. I mean, I kind of figured out what man, I don't know how to describe these things. Basically, what do these signs mean? Like,
yeah.
Yeah.
So this is
where
I
figured out like a few of them, but like.
Yeah, and this is where the curriculum kind of shows a whole bunch of things. And this is where I will say I've seen people use different things. If you look up like ERD, like keys or something like, or not keys, that's probably not the right word, but like symbols. These are different symbols to represent if it's one-to-many relationships, one-to-one relationships. But the main idea, first thing, is that these lines are basically saying, oh, one of the keys, one of the columns in here relate to another column in here.
Right.
And so you can see this employees one. This is basically saying, if you look employee number, last name, first name, extension, email, office code, reports to, job title. Reports to, well, what would that be? Oh, an employee reports to another employee. So what happens is that the value in this reports to probably refers back to an employee number. So basically self-reference within this table. So this is where you might have these connections within here. And you can kind of see here is that you can probably guess is that reports to might report to one person and might report to many people. So it kind of depends on this, like what they have. For example, I'm trying to pull up something that would make a lot of sense. Yeah, these like different symbols, I'll be honest, I never remember it because I can never remember these different symbols.
I think, like, for example, the one with product lines, the products means that product line is going to be a foreign key in products. And like the only place where that's like inconsistent is offices to employees. Offices is not in employees, but it's the same symbol. So that one that was my next question. And I think like the one with, like, for example, order details to orders means, wait, what is that? What is that? I don't remember. Oh yeah, it means that they share a primary key, right?
Sorry, order number and
Like order details to orders. That symbol means that they share a primary key, right?
Well, kind of, because this is where I'm starting to get into a lot of different extra details. Is that order details, the primary key? Oh man, I'm starting to jump ahead. But that's okay. Primary key is basically the thing that identifies, like, that is a unique ID for that record in the table, right? The primary key in order details, well, okay, primary key for let's say orders is order number. The order number is a unique ID for orders. So no record in there will have the same order number. It's a unique primary key, right? And that's in this diagram for the ERD, an asterisk. For order details, can you guys get a guess what the primary key would be for order details?
Order number and product code, it's both.
Yeah, it's actually them together is the actual primary key. So it kind of makes sense because order details, if we did just the order number, you could have multiple, let's say different products, right, in one order. So the order number really wouldn't be unique to each element in the order details. However, if we did something like just the product, well, obviously that's not going to be the same, because what if two different people buy the same product? So there will be copies of that too. So it turns out order number and product code together are actually the primary key. And this is where basically this is relating to what I'll say, like, I don't even like using this terminology because I don't even think of it this way, is your primary key is kind of like referencing in your own table, and your foreign key is kind of referencing within your own table to another table. So and you can say that your order number here, no, I can't highlight this order number is the foreign key that refers to orders, which is this order number. I think, is that close to like what you were kind of getting at?
Yeah.
Okay.
Yeah. Like,
cool.
Yeah, that's what I was thinking in my head, but you articulated it better. Yeah.
Okay, cool. That's good. Yeah, and it helps to talk about it too. And also, like, trying to get the terminology right, it's always like, you hear me trip up a little bit. It takes a lot of practice and I get it wrong a lot. I used to joke is that English is my second language, but I have no first language. Like, that's how I feel sometimes. So anyway, so this actually leads really well to primary and foreign keys. So main thing you have to know about primary keys versus foreign keys. Oops, that's a little mistake. That's okay. Primary key, basically, it's unique to each data row, to each data record. You might hear people talk about different stuff. Basically, it's the thing that says, oh, that is a unique thing. This is a required thing to have in a SQL database, like in a SQL table. It's like, it won't let you do this without defining a primary key. You can possibly have, like I showed here, multiple columns as your unique primary key. However, I will say that tends not, like, it depends on the industry on like what they're doing. So one thing that you'll see a lot of is something called serial. And serial is not like a special thing. It's just that the thing that they use by default of being like, oh, this is the unique ID. And so the serial basically is just a number that has absolutely no meaning at all. It's just basically like literally you might have the first element in like your table be serial 1. And then the next one you insert a new element, like a new row in there, it's serial 2, right? And like 3 and 4 or 5. And then if you delete something, you just get rid of it. So you go like 1, 2, 4, right? So 3 is not there. And then you just keep adding on top of it. So the idea there is that that way it's always unique since they're just adding 1 every single time and they don't reuse the serials. So sometimes in certain databases, you'll see serial use, though I don't think the curriculum ever mentions about serial. And honestly, a lot of online tutorials never talk about serial, but talking to a lot of older companies too with some, data that's been around for quite a long time, this is kind of a common practice. Okay. Any questions on this primary key on like unique and stuff like this? Cool. Equivalent to this like serial would be like a .id. So like ID might be an element in there that's unique to every single one. It might just count up, it might have no significance at all. Okay. Foreign key. So like I said, foreign key basically is just another key within your table that refers to another table's column. So like I mentioned, like order details, order number would be a foreign key to orders. And then product code refers to, in this case, to products. Note that these foreign keys do not necessarily have to have the same name. This could be, for example, let's say they put product, but and this is product code, but it could actually be the same value. Just know that they don't necessarily have to be named the same thing. Though in good practice, it probably should, but data engineers, they do whatever they want. Okay, cool. Any questions at all for anything I talked about? Pretty cool. All right. All right, so then talk about like, what is SQL? Like, okay, it's a SQL thing. We talk about databases. So SQL is kind of like the way you interact with the database. Like I said, it's like old school. Like it's been around for a long time, 1970s. In the sense I say like old school is that basically it's very mature. Basically, it's been used for a long time. It's still being used. And there's a lot of really great things with it. But that also means is that there is a nice familiarity with it, is that you'll see a lot of things that technically don't need to use SQL, which is kind of like a command programming language. It's not really a programming language, it's technically a command language, but you'll see that be used a lot in industry, like in industries and stuff like this and other things. For example, we'll talk about like NoSQL maybe in the future. NoSQL sometimes has interactions with SQL. So you can like write SQL queries that look like SQL, but they're not really SQL. Okay, so who uses SQL? Basically, like almost everyone uses like SQL at some level. Use a lot with data analysts because it's a good interaction there. Many businesses use it. So I would say it's one of those things like, as a data scientist, it's really easy to ignore because it's not super exciting to say, oh, I like writing SQL queries because it's kind of like just getting the data. But I will tell you it's a very useful skill that is good with practice and stuff like this. And then kind of going into like why, SQL is actually really interesting because it's not actually a programming language, it's a command language. You actually give your SQL command to the SQL server, and the SQL server processes this information and then gives you the results, the data. I'll kind of talk about that in a second, but another thing about like why using SQL, it's like super common because it's been around for so long. So pretty much everyone will have some SQL. Oh, also you might notice I'm saying SQL. SQL is also commonly used. People go back and forth. I don't think there's an actual consensus of which one it is, but I will say you will sound like you know what you're doing a little more if you say SQL, because otherwise people just kind of like, how do I say this? So when they first see this, you probably pronounce it as SQL because you see SQL there. But I'll say if you say SQL, it does kind of make you sound better. Not better, but like, just makes it like, oh, this person must know what they're talking about. It's kind of the same phrase of using, data. The word data is not plural. Not singular. It's plural. So sometimes people say data are and stuff like that. It doesn't actually matter. But if you hear people, it's like, oh, it's like you're more elite because you're like, no, you know about your data and you say data are. It's kind of thing with SQL and SQL. Anyway, that's my little tidbit. Okay, so we kind of talked about like why SQL, who uses SQL, a little bit of this. I talked about speed here. So I'm going to kind of tell you what SQL is. So when you run a SQL query, what you're actually doing is you're not actually running it. You're basically taking this command, this select from and all this stuff, the SQL command, we call it like a query, and we give it off to the server. And the server is running some instance of like a SQL server, but know that it doesn't technically have, it has different ways of running. I'll get into that later. But basically you give this command and the SQL server says, you want this stuff? Okay, let me go and collect all this stuff from the database and then package up and send it to you. So what's kind of nice is that SQL, a SQL query is kind of agnostic, is that you're not actually running it, you're not compiling it, like you're not running a different version of SQL on your computer. However, it also means that the server might be speaking a slightly different SQL implementation than what you're expecting. So for example, there's things like MySQL server, there's Oracle's implementation of SQL, there's IBM's implementation of SQL called DB2, and they're more or less, like if you look at them very quickly, you wouldn't really notice too much of a difference, but sometimes there's certain functions and certain things you can say in SQL that won't work in other server implementations. So just kind of be aware of that difference. But because the SQL server is doing all of the work, you don't have to worry about your computer being fast enough and all that stuff. Basically, the SQL server more or less takes your directions and optimizes it as best it can. There are some tricks you can do to help optimize it, but for the most part, the SQL server kind of like takes your commands and says, oh, well, you know, I should like, think of it like a grammar person like going through, it's like, oh, you should put a comma here. Oh, make these into just 2 sentences. Okay, but they know what you're talking about, right? Like, for example, if I say like, you know, me and my wife went to the movies, that's technically incorrect, right? Grammatically, like me, you're supposed to use like my wife and I or whatever, right? And it's like, gets the same message across. SQL Server kind of does that. It's like, oh, well, let me optimize this for you. Okay, cool. All right, that's kind of like a quick intro. I don't know if it's quick, but that was my intro on SQL on this part. And then we'll talk about some code and stuff like that. Any questions about any of the things I've touched so far?
Yeah, I do have one question.
Yeah.
Not sure if it would be answered if I just went further down the material, but the type of SQL or SQL implementation, is that with respect to the database that you're using?
Mm-hmm. That's right. It's all dependent on the database itself.
Okay,
Mm-hmm.
so that'll be like different companies, you know, like this company would use MySQL and different one would use like different implementation.
Yeah, I will say MySQL tends to be more like modern in the sense that like if people are starting new SQL servers, they're usually using MySQL. It's very common in web. However, I have come across like DB2, which is a little rare. Like it's not as common in like web space, but a lot of businesses might use it. But for the most part, you can pretty much carry most of your SQL like commands directly over, except for maybe a couple like efficiency differences or certain functions that don't exist in another SQL Server implementation.
Okay, thank you.
No problem.